Hello and welcome to episode 4 of this SharpC2 development series. In the last episode we worked on generating our payloads, or an example payload rather. We created this payload controller base class, an HTTP payload controller and a compiler. And what we were able to do was basically create a demo application that will eventually be our implant or our agent, and we were taking that source code and compiling it server-side into a .NET assembly. I didn't do the TCP payload controller in the video because it was just identical to the HTTP payload controller. But we did get ourselves into a position where we were spitting out a .NET assembly. I have also created some compiler tests. Now the tests themselves are not especially thorough. So all we're really doing is initiating a logon, starting a listener, and then generating a payload request for that listener ID, specifying an output type and a target framework, posting that request to the relevant API endpoint, and then getting a payload response back. And to pass the test, all we're really saying is the compiler status has to be success, the error message has to be null, and the encoded assembly has to be not null. So all it really proves is that the compiler is spitting out something, but we don't, whether it works or not is a different matter. You can actually take this encoded assembly and then load it via reflection within the actual test, and then run the actual assembly and do some stuff from there. But this is good enough, I think, to prove that the compiler is actually producing something. We're also testing that the compiler fails as well. So we're specifying an invalid listener ID, and then checking that the status is fail. The encoded assembly this time is null, and the error message is not null. We could check the actual value of the error message to make sure it's something that makes sense for this error, but I think the fact that we have tests at all is a miracle, really. And in the end of the last episode, I did kind of think that we could start working on the core agent code, but I kind of thought that we would get into a position pretty soon, pretty quickly within that video, where we would have it be talking to the TeamServer. And the TeamServer, if you remember from maybe episode, I don't know if it was 1 or 2, but the HTTP module was doing nothing other than binding a port. It wasn't really receiving data, it wasn't really sending it back. And we're going to be in a position now for a while, I think, where we're going to be bouncing between the TeamServer and the agent. As we do a little bit on each side, then we would need to do more work on the other side. So for example, in this video we're going to do some more work on the server-side COM module, which I'll expand a bit on in a minute, and then we can start having the core code for the agent, and then we can have the agent trying to do like a check-in process. So we can have the agent generating some sort of check-in request and sending it to the TeamServer, but then we would have to do obviously some more work on the TeamServer to be able to take that request and process it and whatever else. So we will be bouncing around quite a bit now, I suspect. So for this episode, It doesn't look like that much, really. What we're going to be doing is working on this idea of having a traffic profile and building traffic profiles into the listener. So a traffic profile is going to contain, sort of broadly speaking, two properties: a server traffic profile and a client traffic profile. So the server traffic profile will dictate how the HTTP response looks like coming from the TeamServer. So we are going to be able to specify different headers, and a header is just the dictionary string. It has a key and a value. So that could be a cookie, it could be like a content type header, it could be a completely custom header, it can be sort of whatever you want. And then the output profile is how the actual data that the TeamServer needs to send to the agent is going to look. So if you think about that sort of communication process, an agent is going to check into the TeamServer and say, like, hey, have you got any jobs for me? If the answer is no, then the TeamServer needs to basically send back like a no operation type response. If the answer is yes, then it's obviously going to have to send all of the information relevant to that job to the agent. And we want to be able to dress that response up in different ways. So we're going to have a data transform. So we're going to take the message and we're going to transform it in some way. Just to begin with, we're going to have basically no transform and just base64 encode. And we'll think of some others to add in the future maybe. We're going to have prepend data. So do we want any data to come in front of the message that we're sending? And likewise, do we want any data to be like after? And hopefully that'll become clearer how that's going to work as we start coding it. We are not really going to do the client traffic profile in this video, but if we kind of think about what that might contain, that could contain things like the URIs that it's going to try and talk to. So it's going to talk to like the IP address or the domain name of the TeamServer / some fake page or whatever. It could have its own headers. So it can have its own cookie headers or fake authorization headers or anything like that. We can put fake parameters in as well. So if it's checking in over HTTP GET, we can put additional parameters in the URI. If it's sending data back over a post, then you can add additional parameters to that post body, and as well as similar data transform and prepending and appending data. But we're going to focus on the TeamServer for now. So the goal of the video is to write these classes and get these hooked into both the actual listener model that goes onto the COM module, and I haven't written them down here, but we're going to have some methods in the COM module to do these things. And we also need to hook these classes into the API request so that the user can actually specify this stuff that they want. Now if we look real quick at the HTTP COM module, you can actually see there's loads of code in here that wasn't here before. And so what we had originally was basically just this, we're binding, and this, we're closing. And the reason I haven't done all of this in the video is because it's basically just a copy and paste of this code here that Microsoft provide. It's some pretty good example of how to use asynchronous sockets. There's also an example for doing like a client. So this is a server and this is a client. These two code examples work together, but we're not going to be using raw sockets on the agent because we want it to be able to use a proper web client library so it can have proxy authentication and all of those good things. But this was a pretty good example for server-side sockets. So it's basically just a copy and paste. So if we look at our start method here, we've got a new module status property on the class, and this is just a really generic enum that I'm probably going to use for all of the server-side modules that need to know whether they're running or not. So it's when the class is created, its initializer is stopped, and then when we call start, we change it to running, and then we bind the socket, and then we drop into this task where we go on this while loop. So while the module is running, we're going to begin accepting traffic on the socket. And with like all asynchronous methods, we have these callbacks. And the callbacks themselves are not particularly interesting, really. So we hit this accept callback first, and we begin receiving, and the data that we're receiving is getting written into this buffer. The buffer is a static size of 1024 bytes. So, I mean, that's pretty big for like just generic gets and whatever, but if the agent is sending back like a shed load of data, then we will need to think of a way to loop round until we've like finished receiving. We then call this read callback, where we can say, well, this is the number of bytes that we've read now, and this is the actual data that we've received, which, like as I said, it was on this state buffer. Not doing anything with that yet, but if we've read more than 0 bytes, then we call the this send data method, and here we're just generating a static response. So I'm using a string builder at the moment to craft an HTTP response, which is just a string, and then we have to encode that into a byte array, and then we can call this begin send method with our data and its length, and then after we've finished sending, we execute this send callback, which basically just shuts down the socket. So just to see this working real quick, let me log in. And let's create a listener, 8080. And where we go. So we should just be able to do curl 001 port 8080. And here we go. So it's a 200 OK, the content type is plain, and it's hello from SharpC2. I should have also run this in Wireshark as well. Yeah, yes, my life. So if we do that again, this is how it looks in Wireshark. Pretty identical. So let's get started on our traffic profiles. So we're going to have a public server traffic profile. And a public client traffic profile. So we're not going to code that, I'm just going to put it there so, you know, just for reference, I guess. So the server traffic profile will have a public dictionary of string headers. Public class output profile. We can change the names later, and this will have, let's do the public enum data transform. So we'll have raw for no transform and base64. Public data transform, and I'll initialize it as just raw. Public string prepend data, and we'll just say default string. Oh no, we can just say default, can't we? And why I'm not using prop, I don't know. Public string append data. Okay, now if we go into our listener base, not our listener base, listener HTTP class. So we want this here. We'll just call it traffic profile. And we need to find where the request comes in. New HTTP listener request. We'll just call it traffic profile here. And then if we follow these through, so this is where the API request is translated into this listener HTTP class. So what we can say is the traffic profile, if the traffic profile is null or not null, so I think that's how you do it. No, apparently not. Oh, maybe that. Yeah. So this is a strange kind of shorthand for saying if the traffic profile on the request is null, then we assign this property. We create a new, just a new instance of this class and assign it. Otherwise, we use what is in the request. However, if we look at Swagger and go to listeners, you'll see traffic profile is there, but nothing underneath it is. And if we look at the model, it hasn't been able to like expand it out. You click these and it expands out into all the properties. Traffic profile, HTTP traffic profile. So it's not able to expand this. And the reason is we have to have these as properties on the base class. If you take my meaning, so we have to do prop server traffic profile. And now it complains again about naming, so we'll do it that way. Client traffic profile. And then likewise here, we have to do output profile. So let's call this, output traffic profile, output traffic profile. No, can't spell. There we go. So now, I'm pretty sure now it all expands out properly. So that's pretty cool. Okay. So let's think about how this is going to work. We've got some data and we want to send something back. So we're going to send something back either way, even if it's a valid agent request or not. So perhaps in send data, what we should do is send that data into this method as well, data received. And we'll probably need to do something like validate request data received. And then if it's valid, we send send agent task or something. Otherwise, we need to send some go away junk. So we probably want a method to do that. So instead of validate request, maybe we should call this get agent tasks. And let's say that we're just going to return this basically. We're going to pretend that this is our this is the response we want to send. Now part of the reason why I want to send it back as a byte array part of the reason why I want to send it back as a byte array is because it needs to be a byte array anyway to go back down the socket. And when we get to actually construct what an agent message is going to look like, it's probably going to be an encrypted blob, and that's just going to be a byte array anyway. So the more we work with byte arrays, the easier we're gonna make it on ourselves. I don't want to do everything as like strings and then have to come back and like totally rework it. So we're going to say agent tasks is get agent tasks. And even though we're not doing anything with it, we're going to send that byte array anyway. Now that we have that task, what we want to do is transform it. So let's have another let's call it transform output data. So let's call it okay, I'm not too sure how to assign it yet, so let's just work on it. So let's oh no, I can't start it now. Okay, so if we base 64 the response, we can have a big string like this. If we want to prepend something to it, we could say, like, we could prepend data equals, and then this base 64 string. And then if we append something to it, we could say something like and, like something equals else. Okay, this is pretty easy to understand with it being a string, but we might also want to prepend and append just bytes. So maybe we want the response to look like a graphic, and we want to prepend our data with like a JPEG header, the JPEG header bytes or something like that. We might need to look like A1, 2, right? And then our actual data, and then append it with like something else, right? Now, if we were just working with strings, it would be super easy because strings are just so easy to manipulate. When you're working with byte arrays, or really any type of array, they're really awkward because you can't dynamically resize arrays. So you can't just insert data into the beginning or the end. So we have to do like this really weird sort of like copy array dance, I think. So we'll have var trans, or var, no, we can't have data. Transformed data is just a new empty byte array. Var appended data. Or just append data, I think. Or prepend append data. let's do a switch, and we're going to switch on the type of transform, traffic profile, server profile, output profile, wow, this is long, data transform. So we'll switch on that. If it's raw, then the transform data is just going to be the same data that we're feeding in, we're not changing it. Otherwise, the transformed data is convert to base64 string, which is a string itself, so we have to encode that back to a byte array. Get bytes. Okay. Now we're going to say if string is null or empty. Let's copy this. So if the prepend data is not null, then we could say something really simple like the prepped data is just the get bytes of this, right? You'd think, but I don't think this is going to work for us. I mean, it would be fine if it was just a string, but if we are literally putting something like that into the API request, we don't want to get the bytes of like the 0 and then the X and then the 1 and then the 2. We don't want to get the ASCII bytes of each of these. We want to actually just get we just want this like cast or passed to an actual byte. So maybe what we can say instead is if the substring, so if the first 2 characters is equal to X or \X. So actually the way we're going to have them in the request is like \XFF, \X33. So it's going to look like this. So we're going to say is if the string contains this, then we're going to pass bytes. Otherwise, we're going to do this. And then we're going to do the same again for appended data. Append data. Okay. And let's have nope, definitely not a string, a method for pass bytes, and this will take in a string. Okay, and this is probably not the most elegant way to do it, but we're going to say bytes is a new list of type byte, a list of bytes. Now we're going to take the string and we're going to split it on the \X. So this will give us a string array. So we're going to loop through each of those, and we're going to say for each byte string in split. Split is not a great name, but hey ho. We're going to do byte try parse the byte string it's going to be hex format provider, no idea, out byte parsed byte. Okay, and then we'll do bytes, bytes dot add parsed byte. And then at the end, we're going to return the list, but to an array. Okay, so if this doesn't make sense, what we're going to have is a big old string that's going to look like this, right? We're going to split it into an array, so we're going to have an array that will hopefully just be ff. And then, so we're going to loop through each one of these and shove it into this try parse, and it should hopefully pop out a byte. So it should pop out a byte that actually looks like a proper byte, basically. We're going to add each one to a list, and then we're going to change that list into an array. Now I think what I'm also going to do is just put a little check in here to also say if this string is not null. So if for some reason we're getting like a null string somewhere, okay, I hope that makes sense. It doesn't make sense to me. Just saying. So here we can say the prepended data is parse bytes, and we're going to pass in whatever is on this property. And we're going to say the same here, but this is appended data. Okay, prepend pre app. Okay. Now that we do all of that, we have these three byte arrays that we need to combine into one single array. So we're going to have var result is a new byte array, and the size will basically just be all of these lengths put together. So prepended data dot length plus transform data plus length plus prepended append well, that's right, ended end. Words are hard. Dot length. Okay. Then we can do these block copy methods. So this looks quite complicated, but let's go through logically. We'll work front to back. So we want to copy the prepend data in first. So the source array is going to be prepend data. The source offset, we want to go from the beginning, which is 0. The destination is going to be the new result array. We're going to copy from the beginning, and then the count is the amount of data that we want to copy, which is the size of the prepended data array. Now let's copy the actual transformed data. So the source is transformed data. We want to go from the beginning and we want to go into results. Now we can't obviously write to the beginning of the result array because we would just overwrite the prepended data that we've just put in there. So the offset that we want to start writing is the prepended data.length, because we want to copy after that. And then the amount of data we want to copy is the transformed data length. Okay, and then finally the append data, 0 results. The offset will be the prepend data length plus the transform data length. And then the amount we want to copy is the append data dot length. And then after all that, we want to return that result. So this is quite big and it's quite monstrous. I'm not sure I like it very much. So we need to call it. Okay, so agent tasks is the data we want to send, which is hello world. We then want to do something like, what should we actually call it? Let's just call it transformed body. No, transformed data is transform output data agent tasks. Okay, so it's important to remember, I guess, that this variable is basically just this string, just messed around with. So we have the response. So we have this. So now we want to start crafting all the headers and what have you. So we don't want this anymore. So we're always going to return a 200 OK. So what we actually want to do now is loop through the headers that we've got on that listener in the profile. So for each header for each var header in listener dot traffic profile, server profile, headers, we're going to do response dot append. And it'll look like this. Header dot key, header dot value. So the header, this string dot format, header dot key will end up in here, and header dot value will end up in here. So these are positional, right? So if you put a 0 here, it'll be the first variable here. If you put a 1 here, it'll be this. You also need a return a new line. And then after you've added all of the headers, you need an additional one. So let's say var headers is the response. No. So this is a string, right? This is a string builder. So we need to convert all of this to a byte array. And so we'll say headers is encoding get bytes response dot toString. Now again, we have to fiddle around with this again because now we have 2 byte arrays again. We have the headers in a byte array, and we have the data we want to send in a byte array. So now we're gonna say that the actual data to send back is a new byte array, the size of transform data.length plus headers.length. And we'll do the block copy stuff again. So we're going to copy the headers first. And then the transformed data. And we're going to send that back. Now what I haven't really thought of yet is it's all very well and good specifying in the listener static values, but what if it's dynamic? So one of the thing, or two of the things that web servers usually return is a content length and the date. So we could add those here, I think. So let's do that. So we add all of the optional ones first. And we're going to say content length. The content length is just the length of the body, right? It doesn't include all of the headers. So this will be the transform data length. We want a date. Now the date format I think is quite specific. And there's a really good let's see if I can find it. Yeah, whenever I want to know how to format dates and times in C#, I always end up on this page. I think it's a brilliant page. It shows you all of the different ways that you can format your date. So we're going to do date time UTC now to string, and the format I want is, missing a bracket there. So I want DDD for the abbreviated day, so like mon or wed. I then want a comma, a lowercase d for the month number, but that would be, so for single digits that's just like a 1, not a 0, 1, single digit number. I then want the month in abbreviated form, so that's like Jan or Dec. I then want the year, and then just hours, minutes, seconds, UTC. Okay, let's try this. So I want to, let's do this, let's take a copy of that. Let's create a just a normal listener first without specifying anything, just to make sure we haven't broken anything. You can see that the listener model it sends back, all of these things are just like null, and this might cause us a problem if it's null. I think we might get crashed. Yep. Return null. So what I thought I did. Oh no, I didn't. Yeah, it's the only one I didn't do. I didn't initialize that. Hey ho. These are null as well now. I should have checked properly. So you can see that this time this is picking up raw because that's what I initialized it as. Here. So apparently, so I can't do default. I thought the default would just be like an empty string. So maybe I have to do this or string.empty. Let's just do this to be on the safe side, I guess. Third time's a charm. If there's something I'm getting good at, it's typing bearer with just my left hand. Okay, so this is more like it, I think. So hopefully we won't get crashed this time. Ah, we're doing something else wrong. protocol violation. CR must be followed by LF. So I think that probably means we're oh yeah, I forgot the new lines here. Right, 4th time's a charm. Whee. So, okay, we have a contact length of 18. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. Fancy that. The date, Wednesday, 10th of June, 2020. 21, 26, blah, blah, blah. Looks about right to me. Okay, so that's cool. Let's pop that in there. Let's delete this listener. And create a new one. Let's okay, let's not worry about the output profile. Let's try and add some headers. So we could say something like X malware, SharpC2, X something is just blah. Maybe set cookie value equals whatever. Okay, let's try that. They are coming back in our model. Let's just try and run this without stepping through the code. Oh, here we go. X malware, X something. So this is interesting. So curl is like changing the order of the headers, perhaps, because we wouldn't be sending them in this order. That's pretty cool. What does it look like in Wireshark? Oh my god. Wireshark. Yeah, I mean it looks like HTTP to me. Not that I'm an expert. Okay. So let's forget about the headers now. And try this output profile. So prepend data. So we could have something like prepend with a space, and then a space append. So what I'm expecting then is prepend space hello from SharpC2 space and then append. Yeah. That's really cool. Okay, and the more complicated one with bytes. Oh, actually, let's try and base64 encode this first. Base64 data equals and something equals something else. Okay. Yeah, there we go. Data equals blah, 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 and something equals something else. Okay. Now let's see if the byte thing works. So we'll do back x ff. I need double backslash because it thinks it's an escape character. So let's do. So these should come out at 255, 255, 255, 255. Let's just do the same thing. Or let's just do E, shall we? We definitely want to capture this one in Wireshark. So yeah, those characters are not ASCII characters, which is why it can't display them. But if we look here and go to the hex dump view, oh right, yes, oh no, well, this is right, is this right? Yeah, FF is hex FF. If we go to raw, oh god, oh no, it's also FFFFF. Well, I think that's okay, isn't it? Maybe the way to know for sure did that delete then? Yeah. Is to choose a byte that is actually an ASCII character as well. Maybe just like 41, 42, 43, 44, 45, 46, 47, 48. Yeah. A, B, C, D. E, F, G, H. Yes, I'm pretty sure that's working, right? I'm pretty sure that's what we expect. Yeah, okay, I'm gonna call it there. Okay, so now that we have server-side COM module able to return like some data, now we can start, next episode, we can definitely start working on the core agent code and get that talking to the TeamServer. And then probably in the episode after that, we can work on the client traffic profile in the listener, integrate that with the compiler. Sounds like a plan, but we'll see how we go. Right, well, thanks very much for watching. As always, if you have any suggestions or comments, please leave them down below or contact me on Twitter. Okay, cheers, bye.